All right, boys and girls, we're going to look at subtracting mixed numbers again, only this time we're going to look at a type of problem that will occur every now and then. Um, Sometimes I consider this maybe one of the hardest lessons of the year because it can get really confusing. So this is definitely one that you're going to really want to watch and be careful with. This is a good skill, though. I can tell you based off of just my experience teaching, this is something that is definitely going to carry over with you into middle school. And so this is a skill that could be really beneficial. And if you can learn how to do it as a fifth grader, that's really impressive because when I was doing this at your age, I was probably in middle school. I wasn't a fifth grader trying to do this. They've just kind of changed the math over the years. And so y'all are getting a little bit more advanced problems at an earlier age. So let's see if you can watch this video and see if it'll make sense to you. Um, First of all, the type of problem it is. So it is subtracting with renaming. So what that means is you are looking at a problem. Obviously, it's a subtraction problem, but you are taking something away that's bigger than what you have. So it's gonna be really close to and kind of remind you of regrouping when you were younger and when you learned how to regroup and you learn how to go, on a traditional subtraction problem when you learn how to go next door and borrow and regroup. That was the mindset, when you were younger. Well, it's kind of the same thing here. And I always kind of show that as it's developing so kids understand, what is truly happening here. So um, let's look at this problem. I think the first thing that you need to learn as a student is when to rename and when not to rename. So the easiest way to spot it, in my opinion, is looking at your fractions first. So I'm going to underline the fractions. So I don't care about the 4 and the 3 because honestly, the 4 and the 3 doesn't really mean anything right now. Um, when I look at this problem, I have 1/3 minus 4/5. Okay, well, then that's a problem. That's an issue because in the fraction world, 1/3 is a smaller fraction than 4/5. 4/5 is a larger fraction, it's almost a whole. And so in my mind, what I have to think about is okay, I can't do this. It's kind of like if I set up this problem back in second or third grade. So if I set up this problem, y'all would look at it and probably think, okay, well, hold on, this doesn't look right. If I did, okay, 7 minus 10, it looks weird, it looks odd. Or, maybe if it was a problem with like 2 or 3 digits, maybe if it was something like 431 and you wanted to subtract 18 and you just kind of focused in on that first step in your ones place, it looks odd. You can't do that. And so you learned as a younger student, as a younger kid, how to get around that and how to fix those situations. So really, it's the same thing now. You're just seeing it with fractions. So your whole numbers that you've been used to dealing with all your life in math are kind of going away. You're learning more about fractions this year. So we're going to have to really think about what to do in this scenario when we're taking something away that's bigger than what we have. So in this case, we are taking away 4/5, and 4/5 is bigger than 1/3. And so we have to really kind of stop and think about that. And again, it's that thinking part that sometimes will get kids because again, this is just straight math. You're not seeing it in a word problem or anything like that. You're just looking at it and thinking, okay, well, what do I have? Well, if you had 4 and 1/3, well, 4 and 1/3 is bigger than 3 and 4/5. But when you go and you subtract this problem and you set it up, you have to kind of rethink how you're going to set it up. So watch how this works. This is the most important part. So really, really watch this. Okay. So I am going to start with basically the what I have, my total. So my total on this problem is 4 1/3. When you're sitting here and you're looking at it on the screen, you kind of see a mixed number on the left and you see a mixed number on the right. A lot of times I tell my students, like, forget the one on the right for a second. Just forget 3 4/5. We'll come back to that here in a little bit. Let's focus on 4 1/3. So I'm going to just draw like a little arrow here. This is where my focus is going to be. Okay, watch how this happens. So you're going to have a little bit of oh, okay, I kind of see this. I kind of recognize some of the math. And you'll hear some of it when I teach it. So what you're going to do first is you're going to borrow a whole from the 4. And so basically what that's going to look like is you're going to borrow 1. And when you borrow 1, you're going to say, okay, well, instead of calling it a 4, if I pulled 1 away and I borrowed 1, I'm going to call it a 3. But I want it to still show the value of a 4. And so if I borrow 1 from a 4, obviously it turns to a 3. But next to it, I'm going to write 3/3 to show that it's technically still 4. Now, really pay attention to this part. This could be kind of weird. So if I look at my whole number now, my whole number's 3. But if I had 3/3 next to it, 3/3 is really 1. Because anytime your numerator and denominator is the same, you have a whole number. Just like 5/5 is a whole, or 6/6 is a whole, 3/3 is a whole. Well, sometimes kids will get confused there and they're like, okay, well, why are we using 3/3? Well, our original number was thirds. It was 4 1/3. So I don't want to change it to like sevenths, or I don't want to change it to tenths. I want to keep thirds. So if you're looking at it at this moment, I have renamed 4 to 3 3/3. It's the same value. I mean, if you really were just to break it down, 4 is now on the screen twice. It's, I can kind of circle them. I can look at it and go, okay, well, it's here. Well, it's also here, though, because 3 3/3 is the same thing as 4. Okay, so I'm going to get rid of my circle, though. I don't want that to get confusing. All right, now, the next part is, well, I've renamed the 4, but I didn't rename the 1/3. The 1/3 is still sitting there. So I've got to do something with it. And a lot of times I usually just tell my kids, okay, well, hey, if it's just sitting there, let's tack it on. Well, if I tack it on, that language in math sometimes can kind of just lead you to believe, okay, let's just add it. Let's add it on to it. So I'm going to take it and I'm going to add it on, and I'm going to call it potentially, if I really think about this is going to be 3 4/3. And it looks crazy. It's like, what? How does that? I don't understand where that's coming from. Well, what I've done now, though, is I have renamed 4 1/3 to 3 4/3, because now I have the ability to go and subtract 3 4/5. I could not do that originally. I couldn't do that at the very beginning of the problem because 4/5 was greater than 1/3. And so when I've renamed it now, a lot of kids look at 3 4/3 and they're like, how is that renaming 4 1/3? Well, it should all click if you've been paying attention to the math in your classes. So think about it. 4/3 is an improper fraction. 4/3 is really 1 1/3. Like if you changed 4/3 to a mixed number, you'd get 1 1/3. Well, 1 1/3 plus 3, which is basically what you're seeing here at the bottom. If you took 1 1/3 plus 3, you'd get 4 1/3. So really, this at the bottom is now being renamed, or has been renamed, from what we started with, which is 4 1/3. So It's kind of weird. It's kind of an odd type of math to see, but you've done this already. When you learn how to regroup, excuse me, when you learn how to regroup, that's what you were doing. You were basically renaming then. So now you're renaming. You're just renaming with a mixed number, and it's kind of odd to see. But I think the more you do it, the more you'll get used to it. And so here's kind of the thing: we've done all that work to rename, but we still haven't even touched the problem yet. Because now that I've renamed, I can now go and subtract. So that part earlier where I said there's a right side and a left side, and I said just forget about the 3 and 4 fifths and we'll come back to it. Now we're back to it. So now we're at the part where we can go and subtract 3 and 4 fifths. And this is how we can do it. Now we can truly subtract because, and I'm going to use the green here, look, the 4 thirds is bigger than the 4 fifths. I mean, I can now truly do this subtraction problem. I couldn't originally. 4 fifths was greater than 1 third if I go back to the original problem, but now I can. And so some kids are like, okay, well, gosh, we just did all that work. And well, gosh, we still have more to do. What do we do? Well, now it just turns into a regular subtraction problem. It's just subtracting mixed numbers. So if I take the whole numbers, look at the whole numbers. It's 3 minus 3. Well, 3 minus 3 is 0. So what that tells me is my answer is going to be a fraction when it's all said and done. So I'm going to pull off to the side. I'm going to use the same green here. I'm going to pull the 4 thirds and I'm going to subtract the 4 fifths. And some kids kind of get freaked out by this because it's 4 thirds. So what? It's still a fraction. It's an improper fraction, but it's still a fraction. You can still go and treat this just like a normal problem. You could still go find a least common denominator. We've got thirds and fifths. So I'm going to come out and think, okay, what would be my common denominator? Well, if I wrote my 3s and I wrote my 5s, I'm thinking probably 15. And so I'm going to create this new fraction, or fractions, I should say, off to the side, and I'm going to really think about what my problem is going to look like at the end. So I'm going to put my equivalent fractions here. The top one would be times 5. 4 times 5 is 20. Okay, the bottom one would be times 3. 4 times 3 is 12. All right, it is a subtraction problem. I don't want to get add happy here. 20 minus 12. 20 minus 12 is 8. So 8/15 might be my final answer to this thing. I can't simplify 8/15, so I'm thinking that is the final answer here. Now, that's a long, this is about, I've been talking for about 13 minutes here on one problem, but it's something that you have to really stop and think about. This is not something that you will just fly through. You have to really stop and think, what's happening? What do I have to do to get my answer? And all the proper steps that go into it. And I can tell you, not every single subtraction problem is going to be renaming, but you have to know when it's renaming and when it's not renaming. That's really critical, and that's one of the things I always really push in my class. And again, it's not just for 5th grade, it's for the upcoming years. You have to know what you're doing before you do it. So if you see that problem, you have to know, hey, is it renaming? Is it not renaming? Okay, let's look at this next problem here. So this problem, before I even start it, I see that it is mixed numbers. I see that it's subtraction. So my eyes automatically go to the fractions. 2 thirds is almost a whole. 4 tenths, that's less than a half because 5 tenths is a half. So I'm thinking this is a renaming problem. All right, I'm going to go through this one a little bit faster than the previous one. So watch how I do this. Again, think about left side, right side. The right side is 3 2/3. I'm not going to touch 3 2/3 till the end. I'm going to go rename 10 4 tenths. Watch how it's done. So I'm going to borrow 1 from the 10. That's going to call it 9. but I want to rename that 10. So like right now, if I just stopped, I didn't rename the 10. I still want 10, but I have to rename it correctly. So the only way I can do that is to put a fraction beside it that would equal to 10. Well, this particular problem is dealing with tenths. So I'm going to put 9 and 10 tenths as my first part of renaming this problem. And if I kind of just look at what I've done, I have renamed 10. All I did was I took, instead of writing it as 10, I renamed it. So I still have the same value. I still have a 10 being shown. I now just have it looking differently. Well, I haven't done anything with the 4 tenths. So remember, you got to do this part. This is critical. You got to tack it on. You got to add it to that fraction. So I'm going to tack on that extra 4 tenths, which is going to give me 9 and 14 tenths. All right, so if I look at it here, I'm kind of thinking, all right, kind of looks different, but the reality is all I did was just rename this, and I'm going to circle it. This is the same thing as that. 10 and 4 tenths is the same as 9 and 14 tenths. They're equivalent. They're the same. If you drew a picture of them, they would be the same. And again, falling back on your math that you've been doing in class for all these weeks, see the connections that are being made. 14 tenths is an improper fraction. Well, 14 tenths is really one whole, and 4 tenths. Well, 1 and 4 tenths plus 9 is 10 and 4 tenths. So it's the same thing. Okay, so that's the thing. That step right there, if you can get that step down, you have the renaming done. It's done. So when you hear, oh, it's a renaming problem, this is what it is. This is the renaming process. So you've got 9 and 14 tenths. So now I can kind of always tell my students, okay, now it's time to go to work. Because now, really, the hard part's out of the way. Now you're just going to go take this and you're going to subtract whatever you had to begin with. You were subtracting 3 2/3. So I'm going to keep my green here, and I'm just going to write it as, all right, I've got my new mixed number, 9 and 14 tenths minus 3 2/3. All right, we can do the whole numbers first. That's easy. 9 and 3. Well, 9 minus 3 is 6, so I'm going to write 6 down to the side. I'm going to take my 14 tenths, and I'm going to subtract my 2/3, because I can do that problem now. And I'm going to really think about it changing. Again, I'm going back to the basics. I'm just subtracting fractions here with unlike denominators. So I've got tenths and I've got thirds. So if I wrote all my tens have zeros. So if I think about my threes, I'm not going to hit a 0 until 30. So 30ths is going to be my LCD. So I'm going to do a times 3 at the top. And then I'm going to do a times 10 at the bottom. And then I'm going to change these over. So this one gets a little bit harder because you're dealing with a little bit bigger number at the top. So 10 times 3 is 30. 14 times 3 it's going to give you, I believe, 42. You can always do this just to check yourself. But I think you get 42 there. So let's go with 42 30ths. And then at the bottom, you're going to have times 10. 2 times 10 is going to give you 20. And so now you're looking at this problem, 42 30ths minus 20 30ths. And so it's kind of just subtracting here. Got to be smart with it. You can't, take any shortcuts here and make a silly mistake. You've come too far. So if you do 42 minus 20, I believe you're going to get 22. So you're going to get 22 30ths. All right. So I'm almost done with this problem. It's kind of like I've got to sit here and think, I've done a lot of stuff, but it's still not the best it could be, because now if I get down to this answer at the bottom, 6 and 22/30ths, I would still have to think about everything we've been doing in class. Well, what about that simplifying part? So the 22/30ths can't stay. The 22/30ths would have to be simplified. And so if I simplified that, I could simplify it by 2 over 2. I could do 22 basically cut in half is 11. 30 cut in half is 15. And so my final answer here is going to be 6 and 11/15. And that's a lot of work. And it takes a while sometimes to get these answers. But it's nothing, it's nothing that you can't do. It's just something that it's new and it's going to be new, but you got to practice it and you got to pay attention. And that's the thing, when you hit these problems, these could be some of the tougher problems in fifth grade. They really can. And they could be on tests. You have to be prepared for them. I always tell my students, I'm not doing my job if I'm not teaching you everything that you might see. And so this particular type of math, I always kind of talk about this in my class. It may not be super popular in fifth grade. You might only have like one on a test, but in your future you might have more. And it's good to know, and it's good to know and have these skills in your back pocket. So think about this. Watch. I know it's kind of a longer video, but this is a big one. You need to know how to do this correctly.